Good morning. First, thanks to everyone who made the effort kind of getting through the tube strike and train strike to be here. Really appreciate it. As I said, Mark Cooper, I work for a company called AtlasEdge. We're a data center company founded in September of last year, focused on edge data centers. My presentation today is, well, what is edge? So first, going to start with a quick quiz. So over to the guys to bring up the tech with the questions. So first one is, what is edge in 2022? There's two questions, very simple. So first one, do you know what edge is? Yes. Glad to hear that everyone does know what it is. Second question. Interesting. So edge is one of those things where there is no definition of it, and people always seem to associate it with self-driving cars, 5G, IoT. That's not what I'm going to talk about today, because that's kind of the future. That's not what is really happening right now. So if we can flip back to the presentation. So just a short video of kind of what our view is on edge.
To the edge. From explorers to pioneers, our restless ambition is to go higher, deeper, further than the generation before. Today, our digital lives drive us to consume vast amounts of data, and the demand is soaring. How will we deal with such volumes of generated data? By bringing the edge closer to you. Edge computing requires digital infrastructure at the edge of the network. Today, data mainly resides in centralized data center locations. Now we're bringing that data to your doorstep in distributed facilities closer to where the technology is being used. And AtlasEdge is leading the charge to this new frontier by creating Europe's leading edge platform. Our edge data centers provide proximity to the core network, offering seamless, localized and ultra-low latency connections. From the rise of 5G to autonomous vehicles, to gaming, smart cities or virtual healthcare, AtlasEdge will be there, delivering the infrastructure you need for the technology of tomorrow.
So, there's a lot of nice images and words in there, but so edge is one of those topics at the moment where I think it's where cloud was 5 years ago. Now we understand what cloud is, and you associate it with Microsoft, AWS, Google, the ability to move your workloads and data around very easily. Edge, we're at a point where every person you talk to has a different definition of what edge means. Some people think it's 5G, some people think it's IoT, artificial intelligence, high-performance computing. So we're at that point in the industry where there is no clear definition. So what is the edge? So kind of our view on the edge is, if you look at cloud, it's almost like where we were with mainframes back in the 60s. Everything's become very, very centralized. The data's processed centrally. But when you start thinking about new applications, it's how do you actually get the data? How do you actually get the compute closer to the end user? So the one everyone talks about is metaverse and waves their arms and virtual headsets. I'll come to that later. But when you think about it, one of the most important things with edge is how do you actually get to the end user? How do you get to that consumer that's sitting at home using the application on their phone, using their VR headset, doing their cloud gaming? How do you actually connect to them? How do you connect an enterprise? I think one of the amazing things we had with COVID was we went from in an office to working remotely just overnight, and it just worked. And I think that's a great example of how well the internet has been built and how the data centers of today were built, because it just worked overnight. There were kind of a few glitches and tweaks, but it did work. When you think about the edge and going forward, we're going to have to change the way that we connect the users to the data. So when you look at what's happened over the last 5 to 10 years, the telcos have been very, very focused on how do they save cost, how do they simplify their network. So they've actually kind of pulled the intelligence out of the network and brought it back into maybe 1 or 2 locations in a country. So it means that if you're a user in Manchester, your data is probably going to get processed in London and has to go from Manchester to London and back to you. That doesn't work for this next generation of application that's going to be coming. So the network providers, whether it's fixed or mobile, they need to rethink how they're actually going to do the connectivity. How are they going to bring these applications from the data centers to the end user? That's one piece of the puzzle. So kind of changing the way you do the interconnection, doing much more regional-based connectivity. So if you look at the UK, everything's about London. Manchester is starting to come up as the second interconnection location, kind of traffic hub in the UK. And it's going to go deeper into the country as you see more of these new applications coming. So that's what we've done from a data center perspective, is put the data centers closer to where the users are. Don't just focus on London. So look at cities, I keep saying it, Manchester, but Bristol, Sunderland, Birmingham. So having facilities that are really closer to the user, closer to where these applications can sit. And that's a very, very different way of approaching data centers. The other thing we're doing differently as well, rather than building a new data center, we've taken over a portfolio of existing buildings. And those buildings, they have a customer in there, they have connectivity, they have power, and there's existing space in there. So one of the things the data center industry gets bashed on is not being green enough, you're consuming too much power. We're taking the approach of having an existing building, repurpose it, make it fit for the future, use that as a data center, rather than doing kind of brand new builds. So that's one thing that we're doing kind of very, very differently from anyone else. So I'm not sure why they're wearing kind of hard hats inside a data center. I think it's up and running there. But this is, we need to think differently about how we build these data centers. When people think of a data center now, they think of this nice big gray box in an industrial park. It's got a fence around it. There's a security guard, you've got man traps, and it's all just kind of nice and you know what it is. The data center of the future isn't going to look that way. It's going to be very different. If you're running hundreds of data centers across a country, you can't have an engineer on site. You can't have a security guard on site. You can't have this nice shiny gray box. So that goes back to our approach. If you have an existing building, what can you do from a technology perspective? So there's so much that's going on in the IoT space. So with sensors inside buildings, you've got a lot going on with computer vision. So the idea of using computer vision to track what's going on, what someone's doing in the data center, facial recognition for access to the site. So there's a whole lot of technology you can apply to this problem rather than take the traditional approach, which is having humans on site. And humans are expensive. We know it's very, very hard to get kind of good engineers, good security people at the moment. If you look at what's going on with the airports at the moment, the issue they have is there's not enough staff to run the security checks. It's not that the airlines are not ready. So it's about applying technology to solutions and things that we haven't tried to do before. Kind of one of the most extreme ideas is taking a Boston Dynamics Spot robot, so the kind of the dog robots, and using those to do security on site. So you could have it walk around, patrol. It's a bit too kind of Black Mirror for me. It kind of freaks me out, the idea of this kind of robot walking next to me to see what I'm doing inside the data center. But it's kind of thinking about it differently. It's applying technology to problems that we haven't applied it to before. We've been kind of too traditional with the way that we approach data centers. It's this box, and it has generators, and it has batteries. There's different ways of doing it, and that's what we need to think about as an industry. And especially if you're running, as we plan to, thousands of sites across Europe, you can't do that with people. You have to do it with systems. You have to do it with standardization. Otherwise, it just doesn't scale out. So I had to have a picture of someone wearing a VR headset, because that's kind of one of the things everyone thinks about. So computer vision, there's so much going on there already, and it's a great, great example of edge use cases. So think of a supermarket. When you walk into a supermarket, what's going on in there? It's logistics, it's receiving goods, it's probably a DHL point as well for receiving packages for consumers. You've got RFID tags on all the goods in the shop as well. You've got security cameras, you've got sensors. It's this massive IT environment in itself, and guess what? At the moment, it's in a cupboard in the back of the shop. So that doesn't scale. And especially when you start thinking about using computer vision. So at the moment, you can use it for security, what's someone doing? You could use it at the self-checkout to police, did that person actually scan everything? You could have it flag up and go, oh, you put that in the bag, you didn't scan it, maybe you didn't mean to, do you want to rescan it? You can also use it from a marketing perspective. So you're going around the shop, you pick up your bottle of Bacardi or you pick up your bottle of Coke, guess what? They can sell that data on to the manufacturers, and then you get emails going, oh, do you want to buy some Bacardi and Coke? Have you considered this branding? So that there's that side to it as well. And then another example would be petrol stations. Petrol stations, there's a lot going on there, especially in COVID times when it was hard to get staff there. You could actually replace some of the functions the staff are doing with the cameras. You can do number plate recognition. So has this person driven up before and driven away without paying? That can be flagged up. You can use it for kind of security of the site. So there's a lot going on in the retail space. Another example would be, I think it's H&M, where you can go in the shop and you can kind of virtually try on the clothes. So there's so much that's happening in that space. But again, you need to have the compute and the data closer to the user. So you've got the lady here with the headset on. You can't put the compute in the headset because it gets too heavy, it gets uncomfortable. So it's where do you put that compute? How close do you need it to be for the application to work and be kind of be usable? So I don't know why it keeps jumping forward. So with metaverse, that's a great example of everyone's going to be at home with these headsets on and kind of interacting with each other virtually. That's a real challenge for Meta, because Meta at the moment, it's a CDN. It can deliver photos and videos and a bit of text, but it doesn't have the ability to actually stream games or stream video. So that's the question there. So what are Meta going to do? How are they going to address the challenge that Zuckerberg has created for them? And the engineers are kind of scratching their heads and going, well, how do we make this work? So that's another example of kind of edge technology that's coming. This one. So this is supposed to represent online gambling. If you think about online gambling, there's so much regulation there. If you look in the US, gambling regulation varies from state to state. So it's about how do you keep the data close to the user, and how do you make sure you're not breaking any regulatory things. So you do a compute deployment in the state, you keep the data in the state, but you can do the processing in the cloud, but you're not actually breaking any of the laws. And you can see that coming to Europe as well. I think we're becoming more and more focused on data sovereignty, where people really start to think, okay, where is my data sitting? So you have it from the regulatory perspective. The other perspective is there's a whole ton of enterprise infrastructure that still sits on premise. It sits in the building. And it either has not or cannot move into the cloud. It could be because it's an AS400 application or an IBM thing that's just too old and there's no way to move it in. So what do? Do you keep running in the prem, in the cupboard in the back of the office? Or do you try and move it into a data center that's close enough to you that your engineers can get to it, they can kind of deal with it? There's that piece. There's other applications as well that are too latency sensitive to run in the cloud. So when you think of the cloud now, where are the cloud regions in the UK? They're probably in London. There might be some stuff in Wales, but it's not in Sunderland, it's not in Birmingham. And if you have a low latency app, you need a way of having that compute close to you, closer to the end user, closer to the consumer. And again, we've engineered things and we've centralized things, and now it's like, this is not going to work in the future, so how do we start to decentralize? How do you start to move the compute away from where it's been put to? How do you bring it closer back to the user? And it's my first time doing a live presentation for a long time, so apologies for the clicking. It's that challenge. It's where do you put the data? How do you get it closer to the user? How do you connect it to the user as well? So that's what we need to figure out as an industry. It's not just about creating the application. It's creating the compute infrastructure, understanding where that can go. It's about having the location the compute infrastructure can sit in. And then very, very importantly, which I touched on firstly, is you need to think about how you connect it. How do you connect that data to the end user? So the telcos and the mobile network operators, they need to rethink how they've engineered their networks. They need to think about how they do interconnection. They need to think about doing interconnection at a regional level, at a city level. You can't rely on doing everything in London. You need to think kind of broader, bringing it back into the country. And you see some moves there. You've seen all these altnet providers coming. So there are ways that people are trying to kind of meet the challenge of connectivity, make it more regionalized. But it's going to take time, and we all need to work together to do it. It can't just be the data centers going, I built this great data center in Birmingham. If you can't connect it to anything, it's kind of useless. So it's that thing of connectivity. So I've been really, really quick, which I apologize for. So I hope there's a lot of questions. But in conclusion, Edge is here already. I think we're using it every day. You may not think it's Edge, but it's when you're using the applications on your phone. It could be when you're doing video streaming. You kind of classify that as Edge. It probably doesn't match what you expect. It's not self-driving cars. It's not VR headsets yet, but that's coming. Self-driving cars for me is always a strange one that people talk about because they have this image of the cars driving and the intelligence is in the cloud. That's a really bad idea because you want the intelligence in the car because it needs to make decisions like that. You don't want it relying on, oh, there's a cat in front of me, what do I need to do? Do I need to stop? Do I need to swerve? So the intelligence actually sits in the car. The interesting data in the car, so it's producing data about the suspension, the batteries, the power usage. That all gets uploaded when the car stops moving and it connects to Wi-Fi. So there's a lot of data that comes from the car, but the car's not relying on the cloud for the intelligence. The intelligence is in the car, and that's where you want it to be. And it's only going to get more pervasive. So as more of these applications come, as the infrastructure changes, as we change the way we do interconnection, you'll be able to develop apps that right now you wouldn't be able to because it wouldn't work from a latency perspective, it wouldn't work from a connectivity perspective. That's the end. So I hope there's plenty of questions because we've got 12 minutes left and I probably talked far too quickly.
Yes, there are questions actually. We've got one coming in regards to multi-access edge computing and how it works with the 5G networks and 5G services. From your perspective, if you just explain sort of the link between those two.
Yes, this idea of it's this idea of putting small compute at the edge of the network, and then using that to then enable the applications over 5G. I think it's talked about a lot. It's talked about in association with 5G and an approach with Open RAN as well. But the applications are not there. When we talk to the providers, the cloud guys, they're rolling out and they're really pushing MEC and this idea of MEC and 5G, but there's no app that actually needs that compute right now. So I think that's the thing that everyone's looking at is, it's a great idea and it will come, but there's no killer app for it right now because we're almost victims of our own success. We engineered things so well that the internet works as it's currently architected. You know, like I said at the beginning, you went from working in the office to working at home. Teams worked, Zoom worked. Did you have to do anything? No. Was there a lot of people running in the background, upgrading servers, plugging connections in data centers? Yes, but you as an end user, you didn't have to change your behavior. It just worked. I think that's the challenge is we've engineered things really, really well. Now it's finding those applications that don't exist now that will drive the need for MEC.
Thank you. We've got a couple of other questions that are coming virtually, but has anyone got a question from the floor at all that they'd like to ask? No? No? Okay, so just in terms of edge data centers in 5 years' time,
Yep.
What does that look like?
If you listen to us, it's thousands. It's 1,000 locations across Europe. Where we are right now, we're in around 20, but we believe that the demand is there. And you'll do what we call the tier one market, so FLAP, Frankfurt, London, Amsterdam, Paris, and then D, Dublin. You do the tier two cities, so Barcelona, Madrid, Milan, Zurich. But there's a whole tier of cities beyond that, especially when you start going into Southern Europe, Eastern Europe. That's where, for me, the edge the edge really is. It's kind of at the edge of where we've deployed so far.
Okay, thank you. I've got this question that says, give us a killer use case for edge computing.
So right now, for me, the killer use case is retail and computer vision. So it's being able to convert that shop from being the compute in the cupboard in the corner and having it in every single shop, which doesn't scale, it's expensive. It's being able to have that compute in the city, in one location, and then you can use it to serve 20, 30 different retail outlets in the city from one location. For me, that's the killer app right now. It's about retail, it's demand that's there now. It's very complicated because, as I said before, you've got logistics, you've got sensors, you've got fraud prevention, and it's just a really good use case that's real. It's maybe not that sexy, but it's there right now.
Well, I'm sure if it's saved the high street, it would be considered very sexy to a lot of people, I'm sure. Because, I mean, we're basically based in Norwich. It's a pretty good place for shopping, but you notice through my lifetime, all the favourite shops closing and stuff, and you just think, what can they do to stem the tide? And maybe this technology is a way of making it a real experience to shop. So
I mean, you've got this trend of dark stores. So it's where it's things like Gorilla, where you basically order anything and a guy will turn up on a bike with it, whether it's a bottle of Coke, a bag of crisps, and that's kind of tech driven as well. But that's really bad for the high street. And I think technology, we have to find a way of using technology to bring the high street back. Because we don't want to walk down empty streets. You want to be able to walk into a local shop. And it could be that it works because you can automate things, so you don't need as many staff. So I hope they start to come back, because an empty high street for me it's not a nice thing.
Yeah, and I guess what you also don't want is just the big chains that can afford that technology doing it, rather than the cool, quirky, individual boutique shops that we probably would prefer to go in, to be honest. So I would anyway. So
it's a good point.
Hopefully that technology is open to those people too.
Yeah, I think you'll have the trickle down. So kind of cloud has become mainstream. Everyone knows it. Everyone understands it. I think with Edge we're not there yet, but you want to have that point where you can buy your module and it's got your checkout, it's got your camera in it, you can do all the back-end systems for you, and it becomes more accessible.
Accessibility, exactly. Just one final question, and in regards to Open RAN, and how exactly does that drive the edge consumption?
So I didn't hear the question.
So just in terms of the
Open RAN. Okay.
Open RAN. Sorry.
Open RAN.
RAN. I should have said RAN. Sorry.
So Open RAN's being talked about a lot. It's being pushed, but there's no deployments for it yet. The model's not there. I mean, it's a great idea, but the mobile guys are still a bit kind of monolithic. They're tied into using one vendor. So the idea of having this open stuff is great, but it's not there. It's something we're puzzling. We've got someone focused on Open RAN, but that's more about kind of market making. I think you won't see Open RAN come for another 2 to 3 years.
Thank you very much, Mark. Everyone, give a hand to Mark, please.
Thanks, guys.